Okay, I want to just do a quick note about the complexity of the binary search algorithm. And I'm not going to actually do much in the way of proof, but I just want to verbally say a few things. So, the proposition is that binary search takes worst case big O of log n. Now, really, we think about this, as people noted in class, we really think of binary search as taking a time of t of n, is something like a constant times log base 2 of n plus another constant. So, the log base 2, we really think about it as log base 2 because it's halving things, but just a note that binary search, or that the change of base formula for logs is log base 2 of n is log base a of n over log base a of 2. And so the log base a of 2 is a constant, so we don't actually, we usually just say O of log n. Okay, so we don't care about the constant in there. But it's a little more helpful to think about this to see why it works. So let's look at an example. So let's say that n equals 16. Well, each time the algorithm goes through a step, it halves the number of elements under consideration. So, okay, so, first time takes, we'll say, some amount A. Steps goes down to 8. Next time takes A steps, goes down to 4. Next time takes A steps, goes down to 2. And once we have 2 elements, we only have to have one more time. Next time takes A steps, goes down to 1. And then finally, we finish with a single element, taking C steps, we'll say. So if you've seen induction before, this is kind of like the base case, or in our recursive way of thinking. Once we get down to a single element, we're done. And we're able to do this in terms of problems that are half the size. So really, this is like asking, what we're really asking is, we can rephrase this to say that we want to know how many times we need to have this to get 1. How many times we have to have n to get to 1, which is the same thing as saying how many factors of 2 are there in n. Which is simply log base 2 of n. So that's it. So we're getting, getting back to saying how many factors of 2 are there in this, which tells me how many times I have to divide it by 2 in order to get to 1. And that's it. So this is better if you have a pre-sorted array. This is better than a linear search, which is looping through every element. This is much better than a linear search, which would be big O of n. Okay, so this is a nice algorithm. And it'll tie into binary search trees, which we'll get to a little bit later. Okay, but now I want to move on to another topic, another way of searching for elements.